Okay, question 1C. The fuel consumption is at a minimum, so we're trying to find a minimum point, but first we have to find a turning point. Our original function, f, to find the turning point, the function f will have a gradient, so f prime equal to 0. So when the gradient is 0, the function turns like that. And since we have a quadratic, it's going to look like that, or it's going to look like that. That point there is the turning point. That point there is where the gradient is 0. So to find the turning point, we've derived the equation, we let it equal to 0. F prime is equal to negative 0.2 plus v over 125. Okay, so I derived the equation, I'll let it equal to 0. So negative 0.2 plus v over 125 equals 0. Rearrange, solve for v. V is equal to 25 kilometers per hour. Right, we know that is our turning point. We don't know yet if it is a minimum or maximum. We know it is a minimum, we have to prove it. So there are two ways. You can pick a point either side of 25 and see if our value for our original function f is bigger or smaller, and that will help you decide on whether it's a minimum or maximum. But what I'm going to do is use the second derivative method and assess it at 25. So I'm going to derive the equation again. So if I derive f prime to get f prime prime, it will give me 1 over 125, which as you can see is always bigger than 0. If your second derivative is bigger than 0, if it's positive, then you have a minimum. That's because the change in the gradient is positive. So the gradient's getting bigger. So if the gradient's going from negative to positive, then it's a minimum, like this. We have negative gradient all the way down to our turning point, then positive gradient everywhere afterwards. So our gradient is increasing the whole way. That's what f double prime tells us. If our f double prime was negative, then we'd have a maximum, but we don't have that this time. So I've found the turning point. I've proved using the second derivative that I have a minimum. That's the end of it. Okay, this question here I believe was an excellence question. As you can see, it's a kinematics question because it talks about acceleration, and we're going to distance. Now we know that acceleration and distance are separated by velocity. So if I want to go from acceleration, I'm going to have to integrate twice. So first step, I'll integrate. I'll find my velocity. Velocity is equal to integrating acceleration equation. I will write my acceleration equation as 5 minus t over 4. So I've just expanded and simplified that equation there. Now if I integrate, velocity is going to be equal to 5t minus t over 8, t squared over 8. The power goes up by 1 to 2, we divide by the new power. So t squared over 4 divided by 2 is t squared over 8. plus c. Now, what do we know about this train? It starts from rest. That means its initial velocity is 0 because it's resting, it's not moving. It starts at time is equal to 0. So when time is equal to 0, its velocity is equal to 0. Velocity is equal to 0, time is equal to 0. This will help us solve to find what our constant c is. Everything else here is 0, so c is equal to 0. So we can write our equation for velocity as v equals 5t minus t squared over 8, and our constant is 0. Now we had to do that because we couldn't integrate until we knew what c was. So we can integrate v now. Distance is equal to integrating v over time. So s of t, our function s of t is equal to 5t squared divided by the new power minus t to the power of 3 divided by the new power 3 times 8, 24. Now, strictly speaking, I don't need to worry about the c because I could treat this as a definite integral from 0 to 30, in which case the constant would cancel off. But because I'm dealing with 0 as my starting value, I'm going to just treat this as a normal integral, not a definite integral. I'm going to add in my c. What was my original distance? Well, the train starts from rest and we're talking about the distance it travels. So when t is 0, the distance it was from the starting point was 0. If we put t is equal to 0, s of 0 equals distance, 0 equals 5 over 2 times 0 squared minus 0 cubed over 24 plus c. Our new constant c is 0. All I was doing was checking what my new constant was. Like I said, that might not be necessary depending on how you're going about this question, but I've done it, and now I know that my equation s of t is equal to 5t squared over 2 minus t cubed over 24. What distance does a train cover in the first 30 seconds? T is equal to 30. So all I have to do is plug t is equal to 30 into my distance equation. I like to use brackets so that if I've got a negative number, I know when I should be squaring the negative and when I shouldn't be squaring or cubing the negative, like here. Alright, in your calculator that will give you 1,125 meters. Don't forget your units. Okay, that's the end of that question. That brings us to question 2. This here is only an achieved question. The important word is sketch. There are an infinite number of correct answers. There is only one constraint that you have to have. Sorry, 2 constraints. The first one, the turning point is there. That's the point where the gradient is 0. So if we go straight down from here, the gradient function, f prime, has to be 0 at the same x value as the original equation turned. The gradient on this side of the turning point is positive. The gradient on this side of the turning point is negative. We have a quadratic, so our derivative is going to be a straight line. So we just need a negative valued straight line going straight through that point. Perfect, straight line right through that point. Of course you'll use a ruler. Let me try again. Slightly better. The point is that equation and that equation both give you maximum points because they both go through this point here and they both have a negative slope. So the gradient is at its most positive just here. There's the biggest value for the gradient. It is 0 here, it is decreasing in gradient the whole way down, and the most negative gradient matches up with the most negative point on the function. So any one of those straight lines through the point that matches the turning point on the original function will be fine. Only an achieve question. Find the x-coordinate of the point on the graph where the gradient is equal to 4. If we're worried about the gradient, we need the gradient function, which is the first derivative. I have divided the equation. It is equal to 4. What x value, x coordinate, gives me that? A little bit of algebra. X is 8. Find the equation of the tangent to the curve. So here we have some original points on the curve. So we have an equation that goes through those 2 points. That is the equation of a straight line or a tangent. H prime will give us our gradient, our m. X is 1. Our gradient is -10. So I'm going to use the equation y minus y1 equals m x minus x1 for finding the equation of a straight line. I'll use these as my x1, y1 points. Y minus -11 equals m, -10, times x minus 1. Y equals -10 x plus 10 minus 11. Y, my tangent, equals -10 x minus 1. To C, as you can see, G is a cubic. We want to find what values of G. Here's a quick little sketch. For what values of G do we have a decreasing function? So in this one here, you can see that there's a turning point, here's a turning point. Any point in between these 2 points, the equation's decreasing. Our other option for a cubic is this. Same 2 points, but we have a decreasing function here and here. In between those 2 points, now we have an increasing function. So first of all, I'm going to find out what these 2 x values are. I'll worry about whether it's decreasing inside those 2 values or outside afterwards. Stationary points, turning points, G prime is equal to 0. So our derived equation is 3x squared minus 18x plus 24. That has to be equal to 0. You can factorize this. You can use the quadratic formula. You can just factorize the common factor out of all of these values. Here we've got the 2 turning points. They are 2 and 4. Now we have to just decide whether it's between 2 and 4 or outside 2 and 4 that our equation is decreasing. Our function is decreasing. If 2 is a maximum, it has to decrease to get to the minimum. If 2 is a minimum, it has to increase to get to the maximum. So we only need to find out for either 2 or 4 whether it's a minimum or maximum, and it will tell us everything we need to know. So I'm going to pick 2. I'm going to take the second derivative of x. That will give me 6x minus 18. So if I derive this equation here, once more, if this number here is negative, we have a maximum. If this number here is positive, we have a minimum. G double prime at 2. So I'm going to pick this point here and find out if we have a maximum or a minimum. Equals 6 times 2 minus 18. That equals 12 minus 18. That equals negative 6. This is a negative number, therefore x equals 2 is a maximum point. So we have this one, not that one. So we can see between 2 and 4 we have a decreasing function. Decreasing function when x is greater than 2, less than 4. Not including, because the function gradient is 0 there. That's the end of that question. Okay, question 7. Question 2D on page 7. I think it's probably the most difficult question in this paper. So let's have a look at it. We have to maximize the area of this triangle. Maximum possible area of the triangle, we think it's that. What is the area of a triangle? Area is equal to a half base times height. What is the base of a triangle? The base is distance x. The height is the y coordinate, which is going to be ax minus x squared. So a half base times height equals our function for area. We want to maximize. We have to find a maximum point for this equation. We have to first of all find a turning point. We can assume later on whether it's a maximum or minimum, but first we have to find a turning point. That's when the gradient or the derived equation is equal to 0. So if we derive this equation, it's going to give us 2ax over 2 minus 3 over 2x squared. That will cancel off. This is equal to 0. When is this equal to 0? Well, I'm going to factor out the x. Either when x is equal to 0, or you can tell it's going to be a minimum, because if this height here, if x is 0, then the area of the triangle is going to be tiny. It's going to be 0, in fact. So the other option is when a minus 3 over 2x equals 0, or if I rearrange, when x is equal to 2 over 3a. Right, I'm going to put that back in as my maximum value. So this is my x coordinate of my maximum. If I put that back into my original equation, a of x equals ax squared over 2 minus x to the power of 3 over 2. That will give me okay. Hopefully you can follow that. All I've done is expanded these brackets out. 4a cubed over 18 minus 4a cubed over 27. That's the same as 6a cubed over 27, just an equivalent fraction. Minus 4a cubed over 27. That leaves me with 2a cubed over 27 is my area at a maximum value of x, which I got from here. This answer here is what we're looking for. So we've shown that the maximum area by finding the turning point, choosing which turning point we wanted when x is 0 or when x was equal to 2 over 3a. We've found the answer from that.